NEC 250.34 addresses the grounding requirements for portable and vehicle-mounted generators. The code states that these types of generators are generally not required to be grounded. However, an exception exists when such generators are used within or adjacent to buildings or other structures. In these specific cases, grounding may be necessary to protect personnel from electrical hazards. Examining the scenario of using portable generators to power submersible pumps, and these generators are situated outside of any buildings or structures, the requirements of NEC 250.34 do not mandate grounding in this instance. Some manufacturers equip their generators with a lug labeled ground despite the fact that grounding is not always mandatory. This inclusion serves as a convenience for users who may opt to ground the generator for an extra layer of safety. While grounding is not a strict requirement, it is advisable to exercise caution. If a generator is being operated in an environment where the potential for electrical shock is present, it is prudent to ground the generator. This can be accomplished by establishing a connection between a grounding electrode, a grounding conductor, and the generator's designated ground lug. Consider these additional points. Firstly, if you are leasing generators, it's essential to verify whether the rental company imposes grounding as a condition. Secondly, when employing flexible conductors to establish connections between the generator, the disconnect switch, and the pump, it's important to ensure that these conductors are suitable for outdoor use and possess the appropriate ampacity, which is the current carrying capacity. Thirdly, always adhere to the manufacturer's guidelines for the proper installation and operation of the generator. In general, grounding a generator involves creating a low impedance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and energize the circuit in the event of a fault. This reduces the risk of electric shock. Here's a more detailed explanation of generator grounding. Firstly, the purpose of grounding is to provide a low impedance path for fault current. In the event of an installation failure or other fault within the generator or connected equipment, the fault current will flow through the grounding system back to the source, which is the generator's neutral point. This high current flow will trip a circuit breaker or fuse, quickly de-energizing the circuits and preventing a dangerous voltage from being present on the equipment's enclosure. Secondly, grounding reduces the risk of electric shock. Without a proper grounding system, a fault could cause the enclosure of the generator or connected equipment to become energized, posing a significant shock hazard to anyone who touches it. Grounding ensures that the enclosure remains at or near ground potential, minimizing the risk of electric shock. Thirdly, grounding helps to stabilize voltage. A properly grounded generator can provide a more stable voltage output, which is especially important for sensitive electronic equipment. Grounding helps to reduce voltage fluctuations and transients, which can damage or disrupt the operation of sensitive devices. Here's a breakdown of different grounding methods that may be encountered when working with portable and vehicle-mounted generators. Firstly, there is the separately derived system. When a generator is used as a separately derived system, meaning it's not connected to the utility grid, it must be grounded according to NEC 250.30. This typically involves bonding the generator's neutral point to the generator frame and connecting a grounding electrode conductor from the frame to a grounding electrode, such as a ground rod. Secondly, non-separately derived system. If the generator is connected to the utility grid through a transfer switch, it may not be considered a separately derived system. In this case, the generator's neutral point is typically not bonded to the frame, and the grounding is provided by the connection to the utility grid's grounding system. Thirdly, equipment grounding. Regardless of whether the generator is used as a separately derived system or not, all metal enclosures of the generator and connected equipment must be properly grounded. This is typically achieved by connecting an equipment grounding conductor from the generator's grounding terminal to the equipment's grounding terminal. This conductor provides a low impedance path for fault current to flow back to the generator, tripping a circuit breaker or fuse in the event of a fault. Flexible cords and cables used with portable generators must contain an equipment grounding conductor. This conductor must be connected to the grounding terminals of the generator and the connected equipment. Extension cords should also have a grounding conductor and be properly sized for the load. Grounding electrodes are typically made of copper or copper-clad steel and must meet the requirements of NEC 250.52. The most common type of grounding electrode is a ground rod, which is typically 8 feet long and driven into the ground. The resistance of the grounding electrode system must meet the requirements of NEC 250.53. In general, the resistance to ground should not exceed 25 ohms. If the resistance is higher than 25 ohms, additional grounding electrodes may be required. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and quickly interrupt the circuit to prevent electric shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. When using a portable generator, it's a good idea to use GFCIs to protect against electric shock, especially if the generator is being used in a damp or wet location. When connecting a generator to a building's electrical system, a transfer switch is required to prevent backfeeding power into the utility grid. Backfeeding can be dangerous to utility workers and can also damage the generator and the building's electrical system. A transfer switch ensures that the generator and the utility grid are never connected at the same time. Here are some additional safety tips for working with portable generators. Firstly, always read and follow the manufacturer's instructions for the generator and any connected equipment. Secondly, never operate a generator indoors or in a poorly ventilated area. Generators produce carbon monoxide, a deadly gas. Thirdly, keep the generator dry and do not operate it in rain or snow. Fourthly, use only properly rated extension cords and power cords. Fifthly, do not overload the generator. Sixthly, never attempt to repair a generator unless you are qualified to do so. Seventhly, inspect the generator and all cords and connections before each use. Look for damaged wires, loose connections, and other hazards. Eighthly, keep children and pets away from the generator. Ninthly, store gasoline and other flammable liquids in approved containers and away from the generator. Tenthly, have a fire extinguisher nearby in case of a fire. It's important to understand the difference between grounding and bonding. Grounding is the connection of an electrical system to the earth, while bonding is the connection of metal parts to create a continuous electrical path. Both grounding and bonding are important for electrical safety. In the context of portable generators, grounding typically refers to connecting the generator's frame to a grounding electrode, while bonding refers to connecting all metal parts of the generator and connected equipment together. Both grounding and bonding help to ensure that fault current can flow back to the source and trip a circuit breaker or fuse, preventing electric shock. When dealing with electrical systems, it's essential to be aware of the applicable codes and standards. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC provides detailed requirements for the installation of electrical systems, including grounding and bonding. In addition to the NEC, there may be local codes and standards that apply. It's important to check with the local authorities to determine the specific requirements in your area. Here's an overview of some of the key NEC articles related to grounding and bonding. Firstly, NEC Article 250 covers grounding and bonding in general. This article provides requirements for grounding electrode systems, equipment, grounding conductors, and bonding of metal parts. Secondly, NEC Article 400 covers flexible cords and cables. This article provides requirements for the construction, installation, and use of flexible cords and cables, including the requirement for an equipment grounding conductor. Thirdly, NEC Article 445 covers generators. This article provides requirements for the installation and operation of generators, including grounding requirements. It is important to consult the latest edition of the NEC and any applicable local codes and standards to ensure that electrical systems are installed safely and correctly. Improper grounding and bonding can create significant electrical hazards. Failing to properly ground a generator can increase the risk of electric shock. If a fault occurs, the enclosure of the generator or connected equipment could become energized, posing a serious threat to anyone who touches it. In addition, improper grounding can interfere with the operation of sensitive electronic equipment. Voltage fluctuations and transients can damage or disrupt the operation of these devices. Improper bonding can also create electrical hazards. If metal parts are not properly bonded together, they may become energized in the event of a fault. This can create a shock hazard and increase the risk of fire. To avoid these hazards, it's essential to follow all applicable codes and standards and to use qualified electricians for all electrical work. Regular inspection and maintenance of electrical systems can also help to identify and correct potential problems before they become serious hazards. In addition to grounding and bonding, there are other safety measures that can be taken to reduce the risk of electric shock when working with portable generators. These include, firstly, using ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect ground faults and quickly interrupt the circuit to prevent electric shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. When using a portable generator, it's a good idea to use GFCIs to protect against electric shock, especially if the generator is being used in a damp or wet location. Secondly, keeping the generator dry. Water is a good conductor of electricity, so it's important to keep the generator dry. Do not operate the generator in rain or snow. If the generator gets wet, dry it thoroughly before using it. Thirdly, wearing appropriate personal protective equipment, or PPE. When working with electrical equipment, it's important to wear appropriate PPE, such as rubber gloves, safety glasses, and insulated footwear. This PPE can help to protect against electric shock and other hazards. Fourthly, being aware of the surroundings. When working with a portable generator, be aware of the surroundings. Look for potential hazards such as overhead power lines, wet areas, and flammable materials. Avoid operating the generator in these areas. By taking these precautions, the risk of electric shock can be significantly reduced.